here's the dose, and here's the response. And they said that because these curves are all different, then the pharmacology is different of the products. That's what they said. So, let's look at the curve. The first thing is, look at the doses here. 20, 30, 40, 50, 60, 70 units a kilo. Okay, 70 units a kilo. So in a human being, 70 units a kilo, that would be about 5,000 units of toxin. 5,000 Botox units. You would probably kill the person with 5,000 Botox units. But the doses are very high. So what we did was we looked at it. We said, first of all, they haven't taken into account that the units are different. They've given 1 unit of one product is the same as 1 unit of another product is the same as another unit of another product. They also inactivated some of the products. When they prepared the samples, they inactivated one of the products by mistake. And we produced this. So this is the same data that was on the curve. The same data. I haven't touched the numbers at all. All I've done is plot a straight line between them. Okay? It's not a curve at all. It's a straight line. And because they're parallel, in pharmacology that means they have the same mode of action. Exactly the same mode of action, no difference. Okay? And in fact, they actually sit on top of each other. And the difference is because of the unit difference that they use. They didn't take into account that 1 unit of one product is not the same as 1 unit of another product. So in pharmacology terms, there is no difference between how the toxins work in this model, not my data, their data, and they have incorrectly tried to convince everybody that these curves show different properties, show different ways of working. They're not at all. They're the same.
So you say that we don't choose the dilution that we like, but there is a dilution for correct.
Now I'm saying you choose the dilution that you want, but there is no difference in the pharmacology of the products.
Okay.
What I'm saying is that this story to create a difference between the products was a myth. It was a marketing activity designed to confuse people. But actually the real situation is this. Not my data, their data.
Sorry, 1 million question.
Of course.
After dilution, for how many times the botulinum toxin work in the operation?
How long will it stay there?
Yeah.
Probably at least 2 weeks.
Okay.
You can probably store it for about 2 weeks in the fridge. And there's clinical publications on that. People have done that work.
And how many times it takes to have the dissociation between the active part and the non-active protein after the activation?
Less than a minute.
Less. But after the injection or inside the vials?
Inside the vial. I had some slides on that, but we can. It happens in the vial. We thought it happened when you injected it, but now we know it happens in the vial. That it's actually free toxin in the vial. Yeah. So.
Cioè nella fiala.
La dissociazione immediata.
È immediata nella fiala.
Sì.
Io pensavo, questa è ancora più nuova.
So you see, this all fits together. This is old data. We've now got new data, and it all fits together.
We have another question. If in the vial you have a dissociated protein, it means that the dissociated protein is stable without protein?
Yes.
Right.
Yes.
Because if you have a long lasting of 2 weeks,
Yes.
you can use after 2 weeks.
You can
That
use it
it's
and
a stable
it
structure,
works.
not so
Okay.
unstable.
Ah, okay.
It's not as unstable.
Okay.
No, that's quite correct. And what it means is that the other proteins have no role.
Okay.
But it doesn't mean that they're bad. It doesn't mean that they're bad. It just means that they don't have any role. Let's just go on a little bit further. So here we are. So here's diffusion. Diffusion and dose. So again, your question about when does it fall apart? When does this complex fall apart? Okay. And sorry, we already knew that it happened under good physiological conditions because we had generated, see, here's toxin on its own. Here's the complex. So here's all the junk, and here's the toxin on its own at physiological conditions. We showed that a long time ago. And that they showed no difference. In this study, this was a rat study, they showed no difference whether you used high dose or low dose toxin, free toxin or complex. You see, there's no difference here at all, none whatsoever. So it didn't matter whether you used free toxin or you used complex when you did the experiment. You ended up with the same results. Okay. And here are the data for the vial. This is what goes on in the vial. Here's the free toxin in the different products. The products are here. This is zeomin, this is Dysport, and this is Botox. It's dropped off the bottom, I'm sorry. But it's all free neurotoxin in the vial. So instead of it happening in the muscle, it happens in the vial. So the complex has no role, none at all. None whatsoever. It never did have.
No, you know, in diffusion, no.
Never did have. Ever. It couldn't. It didn't exist. It just couldn't have an effect. So, here's a nice picture. I really don't understand this picture at all. I have no idea what this picture means. And I really don't understand this picture. This was a slide at IMCAS. Someone from the presenter. I don't know how you can determine 5 to 7 with this, 1.5 with this, 2.5. I mean, I don't understand. How can you get result? How can you measure that? It's just nonsense. This is the best data on dose and diffusion that there is, that exists. It's from Doris Hexel's group in Brazil. And the background to Doris Hexel's work is she's a very careful clinical investigator, very careful. She does most of the injections herself. She's very special about the depth of injection, always standardized, the angle of injection, always standardized. All of those things are all standardized. And this is her study. So this is a sweating study, okay? We already knew, she had already done the work years ago, that underneath here was a halo of muscle weakness. So it is equal, there is no problem. This is a good model, a good human model. And this is what she showed. She showed that if you took 2 units of Dysport to 1 of Botox, okay, in that study, you saw no difference at all. Diameter, area, 28 days, 112. So you've got exactly equivalent dosing. Exactly equivalent. No difference at all. No difference in diffusion, no difference in anything. No difference in duration, nothing.
Why do you say that 2.0 to 1.0 is the right equivalent?
No, I didn't say that.
What do you say?
I said in her study she found
Right.
exactly that result, okay?
Okay.
And at 2.5, okay, she found a significant difference. Dysport was bigger and better than Botox in that study. So 2 to 2.5 made a difference, a significant difference. Okay? So that's 2 to 2.5. That's not 3 to 4, it's 2 to 2.5. Very small difference. Okay? Very small difference. And here you can see the difference, right? Here is 2 to 2.5 here, and there is a difference between these. She also showed this. She measured the effect different ways. She measured it by different techniques. So first of all, she measured it electrically. What was the muscle activity electrically? And then she took photographs for wrinkle score, okay? And then she measured the size of the halo. And she found that this technique, electrical activity, the muscle action potential, or wrinkle scoring, you couldn't see a difference between these. But you could if you use the action halo, if you measured the halo size, the area, the diameter of the halo. So what she showed here was very simple, but for the first time ever. And that was that the differences between the products depend how you measure them. If you measure it one way, you get one result. If you measure it another, you get another result. But you can get exactly equivalent diffusion, exactly equivalent results if you use equivalent dose. If you don't use equivalent dose, then you don't get the same results.
And the halo is not the same to measure the wrinkle score. Okay. And another thing.
Yeah. Yeah.
So to measure the action with the halo is wrong, or is wrong to compare with wrinkle.
It's showing you that if you use one way, you get one result, and if you use another way, you get another result. That's what it's showing. And no one had shown that before. No one had shown that result before. That was the first time anybody had ever shown it. And that's 2009 on a poster, 2011 in a publication. So this idea that there were product differences just depends how you measure it. It depends. So that's why no one can say it's 2 to 1 or it's 2.5 to 1. Because you're 2 to 1, maybe you're 2.5 to 1, maybe you're 2.3 to 1, maybe someone else is 3 to 1. There's plenty of people converted at 3 to 1 who're very happy. There's plenty of people converted at 2.5 to 1 and they're very happy. So you can't have a rule. There's no such thing as a rule in this world. And there have been a couple of reviews published on ratios, and they've come to the same conclusion that these old numbers, do you remember these old numbers that it was 3 or 4 Dysport units to 1 Botox unit? They're way too high. You were overdosing with Dysport, just overdosing. Here's another example. This is hyperhidrosis now. And this is going out to 6 months. And you can see here that at 2.5 to 1 to 1, you get a stronger effect with the Dysport product than with the other two. It's a dose thing again. You get a different result with a different dose. That's it. So,
on your opinion, why the FDA needs to stress the interchangeable, the interchangeable of
non-interchangeable.
Yes.
Because of things like this. because, you know, someone could do a huge study and demonstrate equivalence, and then those data get translated by other people in the world and it shows to be the opposite. I just want to scan down a second, if you excuse me. You asked me to talk a bit about comparative clinical studies. And I think comparative clinical studies have a real issue. Actually, they have a number of issues. And the first issue with comparative studies is who sponsors the study? Who pays for the study? And there are a lot of people now that believe that one company pays for a study and they get one result, and another company pays for a study and get a different result, and so on. So we have to remember that. But I actually don't think comparative clinical studies are very helpful to you now. I really don't. In fact, I think they're very confusing, and I'll try and show you why. So here, I'm going to use this example because this is a current example about confusion, about these comparative studies. So here is Bokuture, okay? And in the SPC for Bokuture, it says the standard dose is 20 units. Okay, 20 units, the same as Botox. But it can't say that, but it says it's 20 units. Okay, all right? And the main studies to support that were comparative studies. 20 units of Botox, 20 units of Bokuture, yes, and they showed the same result. The so-called non-inferiority studies, non-inferiority, okay? But then, war has broken out, a war between Allergan and Merz. Because many people in the world believe that the Xeomin product, or Bokuture, did not give the same effect with the same dose as Botox or Vistabel. Many people. It didn't have the same strength of effect, it didn't last as long, blah, 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 blah.
And I agree with them.
So war broke out, a war. And the companies, they took each other's product and they measured each other's product in the laboratory. One company said they're exactly the same, and the other company said, no, there's only 75 units of Xeomin in a vial, not 100 units. And so war. Okay? So here's one of the first shots in the war. This is an Allergan-sponsored study from work done in Germany that used 20 Botox units, but 30 Xeomin units, okay? And they said, okay, that's the equivalence, 20-30, right? Not 20-20, but 20-30, right? So that was the first battle. Next comes the next battle. And the next battle is Merz doing a study that says, no, it's 30 Botox and 20 Xeomin, okay? And here's the results, 30 Botox, 20 Xeomin.
It's the relativity theory.
So, is it 20? Is it 30? What is it? Okay? So the next battle has now happened with this latest publication, all right? It's not 20, it's not 30, it's 25.
It's a compromise, yeah.
And this is a Merz paper. So Merz have all of a sudden decided to say it's not 30 or 20, it's actually 25. So this is why I think comparative studies are really confusing. Because as of today, I really don't know whether it's 20, 25 or 30 that's equivalent one to another. Because I've shown you all the evidence there. And I don't think it's helpful to do these studies. I call it the 2030 war. We're writing a paper on it. It's a couple of guys and me. We're writing a paper on it at the moment because it's so confusing. So the conclusion of the 2030 war is it's 25 units. Here's another reason. This is a very interesting study that Nick Lowe did a few years ago, trying to compare Dysport and Botox together. And he showed that, in his opinion, 20 units of Botox gave a better result than 50 units of Dysport. Okay? So it was the same at 2 weeks, and he had these data afterwards, 2, 8, 12, 16, 20 weeks. All right? Remember that, please. 2 weeks, 8 weeks, 12 weeks, 16. Right? He then did another study. Okay? Same study. Different patients. Now it's 8 weeks, 12 weeks, 16 weeks. At 8 weeks they're the same. Not 2 weeks, but 8 weeks. If you remember before, they were different at 8 weeks. Now they're the same. And look, the responders were 50%. Terrible. They've suddenly become 95%. So we've got 2 studies here by the same group on the same ratios, the same products, that show 2 completely different effects. Okay? And in reality, Bertolciani and Alex Nass, they wrote a letter about it to show that in fact there was some very, very strange data in the Lowe study, and they really felt that it wasn't good data to use. So again, comparative clinical data is a real problem because it can show what you want. It's really not helpful to do it. Comparing toxin to placebo is good, it's useful. Comparing it to another toxin is not helpful because you will never be able to demonstrate that they're the equivalent. You'll only ever be able to show that they're different. And here's another study, and this study was on crow's feet, okay? And it hit the web. It hit the web in 2011 because everybody thought it was a great result, a wonderful result. And this was a study of Dysport against Botox in the crow's feet, okay? And they found Dysport had a much better effect. Fantastic. But when you look, it's because they used 3 to 1. They used more Dysport. It wasn't an equivalent dose. And the reason that they used 3 to 1, of course, is because in the States, the aesthetic Dysport is 300 units. And Botox cosmetic is 100 units. They wanted to show a vial to vial comparison.
Yeah.
And here's another study as well, 2.5 to 1, which showed that they were identical, but it's a very weird study, a very strange study. Here's some other comparative studies, which are quite interesting. They're interesting because they're quite quantitative. They've done a lot of different measurements. And this is the forehead studies of Mark Nestor. It's 3 publications about measuring the effect of Botox and Dysport in the forehead, a comparative study. This is what they used. This was their injection pattern. 2.5 units of Dysport to 1 of Botox. This is what they measured, so very quantitative measurement of the position of the eyebrow. Some pictures for you to show what they found. And you can see here the different grades. Initial onset, full onset, and then complete onset. They made different time points for their measurements. This is what they found for onset. So 20% of patients with Dysport responding in 6 hours, and a significant difference at all these time points. And this is what they found for duration. A significant difference depending on the scale and on the measurement points between the products. I'm very concerned about this study because to me it's a good study. It uses validated scales, quantitative scales, 2 different scales. It's a carefully done study. Okay, there's not so many patients, 40 patients, but they have such a big difference in the results of the products for a very small difference in the units, 2.5 Dysport to 1. This difference is too big for me to explain by dose. Something else is going on here. We wait to see if someone else can reproduce this. Here's the study I've mentioned about preservative saline, and preservative-free saline there. An improvement, a significant improvement in the pain. So I think comparative clinical studies, people like to do them. I think it's very difficult to use them to come to any conclusions, because for every study that you can show of one thing, you can show a different result with something else. And I think that this, if you change products, you have to find your own way. You have to use numbers as a guide. But the best guide is what the recommended dose is in the box. You know, if the recommended dose is 50 units or 20 units or whatever, that's the best dose to start with. And I think anyone that's training on the products, I think we should discourage them from thinking about ratios and comparisons like that. I think we should say to them, use what's in the label, use the labelled units of the product. Don't use 2 to 1 or 2.5 to 1. I think that's confusing. Do you want to talk about adverse events?
Yes, please.
Okay. So these are all the different sorts of botulism that you can have from food and so on. And we've now got a new sort of botulism, which is, can a doctor give a patient botulism with an overdose? And the answer is yes, you can. But not in the world of aesthetics. It's never been reported in the world of aesthetics. With an illegal, unlicensed product in America, it has been done. Okay, but not with a legal product. But this part here is very interesting because, of course, what we're really thinking about is accidents. So, oh dear, I'm sorry, it's gone off the top. Here are 3 accidents that are reported. The first accident is people working around the eye. Oh, and it drips, and it goes in the eye. Drip. And what happens? Nothing. Nothing happens at all. And the second one is we're working around the eye, and oh, I've slipped, and the needle punctures the eye. That's what happened in the second one there. And what happens? Nothing. And the third one is ridiculous. But someone with spasticity was in hospital, and they were receiving intrathecal drugs, and someone by mistake gave them toxin intrathecally. Quite a dose. They had some problems with feeling in their legs, but in the end, feeling, sensitivity,
really?
Yeah, and pain as well. Yeah. So if it does go to the central nervous system, if you inject it in there, there's no doubt about that. But otherwise the patient recovered. How on earth that happened, I really don't. I think they were meant to get baclofen, intrathecal baclofen, and they ended up with toxin.
They just had a New Year's Eve party or something. They were probably drunk.
This is the European way of classifying the adverse events. The most common adverse events, there's 2 really. One is hematoma, and the other is headache. And headache, of course, is a very strange side effect. But we still get that. And then we have these other ones down here, these different ones. Very, very rare to see something like an eye movement disorder, something like that. Very rare indeed.
Do you think that in a first trial many years ago, the people learn, we learned that we must inject onto the bones in the frontal area, and after we go a little bit up. And so this puncture of the bones can create a little bit of headache.
And I think as the years have gone by, and the investigators in the trial got more experienced, I think the adverse event picture changed a lot. But also there's a big difference between Europe and the US in what's reported. So here you can see that some of the adverse events that were reported in the trials in the US had, for example, well, upper respiratory tract infection. How do you get that from toxin?
Yeah.
And nausea. Well, I mean, I think you could get nausea because some patients get wound up, really sort of stressed.
Yeah.